Chapter 5, Section 4, Problem number 19. The weights X of eggs produced at a particular farm are normally distributed with a mean of 1.72 ounces and a standard deviation of 0.12 ounce. Eggs whose weights lie in the middle, 75% of the distribution of weights of all eggs, are classified as medium. Find the maximum and minimum weights of such eggs. These weights are endpoints of an interval that is symmetric about the mean in which the weights of 75% of the eggs produced at this farm lie. Let's do some drawing here this time. So I've got this bizarrely shaped, supposedly normal distribution here. I've got a mean of 1.72 ounces. It's going to be my mean. And what I'm looking for is a range, so that in this range I have 75% of the distribution. So at least 25%. So out here I've got 12.5%, and on the bottom side there's 12.5% sitting out there. So I've got this value here, which is some distance, and the value there, which is some distance, and that's symmetric, so let's just call that a distance A. So at some point 1.72 minus A, and at 1.7, I've got the 0.72 plus A, at that point is where, between those 2 points is where I have 75% of the distance. So this will be the lower point and higher point, the low range and high range of what's going to be a medium egg. That's that 8 there as well, so I'm going to subtract and add as I listed there. Alright, so from our distribution standpoint then, what we're going on, since we have a normal, we mentioned earlier, this is normally distributed. Okay, I didn't note that earlier the standard deviation is 0.12 ounces. I didn't state that. So we can use the transformation back to the standard normal distribution to get some values here. So essentially what I'm looking at is the probability that 1 minus 0.72 minus A is less than X is less than 1.72 plus A. And that's going to equal those two together, which is those the remaining percent, 0.25. Okay, we've done things like this before. There's just this extra A tossed in here this time. So we can take this and convert it, like I was doing before, the probability of whatever this value is minus A. There's that. It's going to subtract off the mean, 1.72, and divide it by the standard deviation, 0.12. That's going to be less than Z, which is going to be less than 1.72 plus A, plus my mean, 1.72, divided by 0.12. That's going to equal 0.25. Okay, let's see where I'm going to take this next then. I can go and subtract those off. I can also look at this and say each of these are going to be the same, these areas and these tails. So let's just look at this first tail here. So this first tail is going to be, I'm going to have the probability that, oh, stop going crazy on me. Probability that Z is less than, I subtract all this off, this 1.72 comes to there, I'm going to have minus A over 0.12, that's an A, not a 9. So that probability is going to equal, I had it back over here, this is 0.125, where I could go back and say half of the 0.25 that I had created back again. So again, this is the Z star here, so Z star is going to equal Well, there's nothing there, so the probability that Z is less than Z star is going to equal that 0.125. So that Z star is where I have 0.125 probability, so that goes back into the table. I go back into the table to look at the 0.125, and 0.125 is at minus 1, no, there's a 0.1251, which is at Z star equaling minus 1.15. Okay, so I have, let's go back up here, I have minus 1.15 is Z star, which is minus A over 0.12. So multiply that together, look at the A's, so A equals, okay, so when I finish that multiplying, this is the 0.138. So my probability, so the values of X are going to be the 1.72 minus 0.138 and 1.72 plus 138. So that range is going to be, so I need to go between subtracting the, back up here, the 172 minus A is going to give me 1.58 is less than X is less than 0.138 plus 172. It's going to give me 1.86. So, medium eggs are between 1.58 ounces and 1.86 ounces for this particular farm.